We wish to discuss the flip-flop chain, which is an example of a Markov chain with two states. It is a model for the basic flip-flop switching circuit. Such a circuit is either open or closed. In other contexts, it may be on or off. We begin by assigning the state space S to the two states. If x n equals 0, then x n plus 1 equals 1 with probability A, 0 with probability one minus A, independently of the previous moves. Then we have that small p of 0, 1, which is given by the probability big P x n plus 1 equals 1, given x n equals 0 equals A, and P small p of 0, 0, that is the probability of x n plus 1 equals 0, given that x n is 0 equals 1 minus A. These small p's are the entries of the transition matrix. So we have got a transition matrix. We know that there are two states and it has to be a square matrix. So we have P naught naught, P naught 1, P 1 no, 0, P 1 1, and so far we know that P naught naught is 1 minus A and P naught 1 is A, so we can write down the transition matrix as where we need to find what P 1 0 is and P 1 1 is. P 1 0 equals B and P 1 1 equals 1 minus B, so that our transition matrix reads so our transition matrix looks like this. The associated state transition diagram looks like this. As an example of a flip-flop Markov chain, let's consider that on a table there are k plates of soup and there is a soup tureen. A fly which is initially on the tureen is equally likely to move from any plate or the tureen to any of the k vessels. And we wish to find the probability that it is revisiting the tureen after n flights. For a plus b, the sum of a and b being greater than 0, the n step probability of a flip-flop Markov chain reads as mentioned earlier, the flip-flop Markov chain has two states. In our case, we have that the fly initially is on the tureen and the other state being not tureen. So what are the entries of the transition matrix in our case? P naught naught equals 0 in our case, and P naught 1 equals 1. P1 naught equals 1 over k, which is a probability which can be expressed as k to the minus 1, and P11 is simply 1 minus 1 over k, which equals 1 minus k to the minus 1. So the transition matrix in our case reads the n step probability for the flip-flop Markov chain in our case is then given by which equals which then equals to finish our example, we notice that we can write the solution in our case as